Alrighty, we are live. Hello, everyone. Welcome to this particular live webinar on observing Kafka at scale with OpenTelemetry. My name is Kunal. I'm working as a DevRel engineer at Randoli, and I'll be your host for today. And I'm joined by Rajat and Shrimal from the Randoli team. Let's go over through a quick round of introductions. Rajat, would like to go first?
Yeah, sure. I'm Rajat. I'm the founder and CTO for Randoli. Very excited for today's webinar.
Shrimal?
Hi, Ron. So I'm Srimal. Like I've been working in Randoli for almost 3 years, and we are building some exciting features here. So yeah, very excited to present what we are doing here today.
Amazing. Yeah. So today we are going to talk about observing Kafka at scale and just a couple of housekeeping things before we start. Because we are live streaming on LinkedIn and YouTube. If you want to chat with us, which I would definitely recommend that you do, you can ask your questions. This is basically the link for the YouTube live stream because LinkedIn sometimes lags when you chat. So I wouldn't want you to have that kind of an experience. And feel free to ask all of your questions throughout the entire session. We'll definitely try our best to take your questions, your thoughts, and your experiences after the end of this particular session. But with that being said, Rajat and Shrimal, take it away.
Sure. All right. Awesome. Kunal, you wanna sort of
Yes.
share the screen? Yeah. All right. So Kafka is a remarkable piece of software. It's not a stretch to say that a lot of teams depend on Kafka to be the backbone of their production systems, right? It is arguably the sort of the go-to choice for event-driven architectures, and generally considered the backbone of most production systems out there. And like I said, it's a remarkable piece of software, and yeah, generally holds up really, really well under adverse conditions. But it's the situations around it that makes it a little bit tricky to monitor. So let's kind of go through a bit of a story here. Let's say you are, in this particular case, the customer deployed an application. They made a change, and the deployment was done around 11 a.m. What was different this time was due to a slight change in code, there was some extra processing time that was added in the code in the form of a faulty retry. But all was well. You did the deployment, and your team is monitoring Kafka. Your team is monitoring the applications. No problem. Um, by the afternoon, those milliseconds have slowly caught up. Every message there was a couple of milliseconds, and then towards the evening, when the evening rush hour came, there was more messages that are now coming into the queues. Slowly, the processing has slowed down, and by around 10 p.m., there's considerable amount of messages that are piling up in the topic. Now, because the consumers are starting to slow down, there is downstream effects, and it's affecting the rest of the system. And by 2 a.m., you have a full blown production incident. Even at that time, if you look at it, your brokers are all showing healthy green, no problems. Your applications are looking okay. There wasn't a much movement in CPU, perhaps a little increase in memory, but not a lot to look. When you look at when you observe the applications in the broker, you can't really say much, but your system has ground to a halt, and you have a full-blown production outage. And that's the kind of stories that we want to talk about today. How can you identify scenarios like that? How can you, build guardrails in your monitoring observability to handle situations like this? All right, so let's get started. Shall we kind of look at the agenda today? All right, so we'll start by looking at the critical metrics we want to monitor for the broker, the consumer, and the producer. We'll talk a little bit about what the traditional monitoring looks like and compare and contrast that with the alternative approach. And then we are attempting to do a real failure scenario, a couple of failure scenarios. Live demos are always fun. Let's hope the demo gods are with us. All right, so let's dive into um, the broker metrics, right? So can we let's roll forward. All right, good. Okay, so let's talk about the broker side metrics here. Um, Freeman, you have been involved in dealing with actual production systems that were very, very heavily reliant on Kafka, right? And often, there are some what I would call leading indicators of trouble, right? So let's talk about offline partitions. Why is offline partitions important? What is the effect on the consumer and producing applications and the broker itself? Let's start there.
Yeah, yeah. So offline partitions like one of the very critical, piece of metric that we need to keep an eye on. Uh, Sometimes like Kafka is a system which allows parallelism through partitions. So like we can create topics and we can create multiple partitions, and that's how it distributes the load. So like consumers can consume from like those partitions, and that allows us to run multiple consumer applications. Partitions has a config called replication factor. So like if you don't have replication factor configured properly, let's say we create a partition and with a we create a topic with a few partitions, and the replication factor is what that means we only keep one replica of that partition. So whenever the broker which holds that partition goes down, that partition becomes offline. That means producers are not able to produce messages, and consumers are not able to consume anything from that partition. So that's why offline partitions become a very critical metric. Whenever a partition goes offline, that means that for sure that is going to make an impact on the system. So because of that, we have to treat this metric is a kind of very critical one.
So great explanation. So Srimal, you brought up a good point. I know this is purely about monitoring, Kafka, but I think it's worth explaining a little bit about the partitions and the replication factor, right? So you talked about a situation where if the replication factor is one, and if the broker that happens to have that partition goes down, then that's completely unavailable for the producers and consumers. Now, in general, most people run a minimum of 3 brokers in production, and teams often think, you know what, I can tolerate one broker failure, but may or may not pay attention to the replication factor. So it probably it's for some situations maybe you are okay with having a replication factor of 1, but for all your critical topics, you should at least have a replication factor of 2 or 3, and the the trade-off there is the higher the replication factor, the more the broker needs to work to keep everything in sync, right? It's a fine balance between high availability and performance. But if you are if you have a couple with replication factor 1, then you want to make sure that any time a broker goes down, you might be able to tolerate a couple seconds or minutes of sort of outage, but your team is fully aware and you attend to the issue immediately. Yes. Yeah. All right. Awesome. By the way, if you have any questions, please, feel free to ask. And Kunal, just alert us. I'm not keeping an eye on it, so let us know if there's questions. They'll be happy to answer as we go. All right, Sriman. So, what about active control account? Can you explain why that's important and to monitor?
Yeah, so Kafka cluster should have at least like there should be one active controller in the cluster. So active controller is the one like who takes care of partition lead assignment. Like it is the one like who manages the cluster. So at a given time, we should only have one active controller. If we see like more than one active controller in the cluster, that means there's a strip drain condition, like quorum is not maintained properly. And if you see, like zero active controller, that means cluster is not functional because there's no active controller. So that's why active controller count is super critical. Like we'll have to keep an eye on it because active controller count is, like zero or more than one. That means we have a non-functional cluster. That for sure that's going to make, like impact on all of your consumer applications, producer applications, and data pipelines. Yeah, so that's going to be super critical.
Gotcha. I We didn't mention it here. From an availability point of view, we may have to think about Zookeeper too, because not everybody is on care of mode yet. Can you talk to us a little bit about the Zookeeper side as well?
Yeah, so I think yeah, Kafka recently introduced CareApp. That means it maintains the quorum internally. So it it has the ability of like keep all those state changes internally in the Kafka cluster. So we need to have at least like three brokers running if you are using CareApp. But earlier versions, I think that's like most widely used versions of Kafka still uses Zookeeper uh, as state storage. And Zookeeper is the one like who maintains a quorum. Like we need to have at least three Zookeeper instances to like maintain the quorum. And Kafka cluster like just uses that Zookeeper cluster to keep all those metadata. Like if you take active controller like the election process, like whenever we start the cluster, one broker is going to create a key in Zookeeper, and it will keep like refreshing that key. That's how it becomes the active controller. So Zookeeper is super critical in that case because that's the like heart of Kafka. Like that's what like keeps all those keep the state of the cluster. And yeah, all the topic information, sometimes the broker metadata, everything is kept in Zookeeper. So that's going to be super critical. So we'll have to keep an eye on Zookeeper as well in that case. But in recent versions, it's just going to be Kafka brokers. If we have at least, like three Kafka brokers, cluster will mostly be functional. Uh, yeah, I think that sums it up.
Gotcha. Yeah, you also mentioned about like so with care though, like you need the for quorum, you need a minimum of three, right? So that means we have to also monitor a minimum number of brokers in production if you're using care off mode, right? Yeah. So that's actually pretty important as well to kind of keep in mind. Yes, very good. Okay. All right. Any questions? Please keep it coming. Happy to answer. All right. So now we talked about the availability of the broker side. Let's go on to the sort of like the durability side of it. So um, why should we think about under replicated partition? What is under replicated partitions and why does it matter?
Yes, so we talked earlier a partition can have multiple replicas, and in a
Hmm.
production systems we need to have at least three replicas. So that's the standard. Uh, so if a partition is not able to fetch updates in time from the partition leader, like we have like in Kafka, we have even if we have multiple partitions, there's a leader elected for each partition. So that acts as the partition leader. That is the partition who is catering all consumer requests and produce requests. So followers are replicas are like just gonna be stay in the passive mode. So if one of those replicas are not able to like keep up with the leader replica, leader partition, then that partition becomes an under-replicated partition. And with this, we have to think about in-sync replicas as well, because for each Kafka topic, we can configure number of in-sync replicas. That means how many of those partitions has to be in sync with the leader at all the time. So like if we have unreplicated partitions, that is exceeding the number of in-sync replicas, minimum number of in-sync replicas, that's gonna be that partition is gonna be under min ISR. That means the partition is not able to keep the minimum number of in-sync replicas active. So in that situation, if a broker goes down, we will be surely end up with having a data loss, because uh, the new leader has to be elected, and new leader is not in sync with the partition leader. So we are going to lose some messages in that case. So that's why we need to keep an eye on this metric, especially unreplicated partitions, and we need to configure min ISR count properly, at least 2 min ISR.
Being ISRs, yeah.
Yeah. So that would help, whenever broker goes down, we can make sure we have at least one replica available to take over the load.
Gotcha. Okay, good. So this is so it's very critical if you're looking at a well, I mean, I'm not a big fan of just staring at dashboards, but if you're doing any kind of monitoring, it's very important to keep an eye on these two metrics and get on top of it right away. Right. Good. Okay. Great explanation, Frima. Let's now switch track towards the performance side of things, right? Generally, like I said, Kafka has a pretty good reputation on how to, to handle, millions and millions of messages. It's a very well battle-tested, proven piece of software, but things can go wrong. And not to mention, Kafka is written in Java, so there's the JVM aspect of it as well. Poorly configured Kafka clusters can cause a lot of grief. So we haven't sort of mentioned those metrics here. We'll talk about it when we actually describe those in the when we talk about the dashboard. But let's talk about the performance related aspects of it, apart from the resource usage, because I think most people know that they need to look at memory, CPU, especially keep an eye on JVM, JVM metrics and stuff like that. But what are the other things that you should keep an eye on? So let's start with the sort of like the maybe the disk aspect first. Sorry, we'll start with the performance of like the messages coming in and going out kind of scenario. What about the request latency, and is there anything else that you feel is important that's not mentioned here? Let's chat about that as well. Yeah, go for it.
Okay. Yeah. So if you take a closer look at the Kafka protocol, it's a bunch of requests and responses. So if you take a look at the documentation, they define these are the requests that a broker supports, and these are the responses that it provides. So even if you publishes a message, that's going to be a request. So it has an API key, and it has a binary payload. So and it holds a batch of messages. So when it comes to Kafka broker side, what it sees is these requests and responses, and the duration it takes to fulfill a request or generate a response. So that's what we see from Kafka broker's perspective. So it's important to keep an eye on these metrics. I mean, fetch and produce is just API keys. They have API key for fetch, API key for produce. That's how they identify different message types. So we'll have to keep an eye on the latency of each of these message types. So if you see an increase in fetch latency. That means the broker is not able to fetch messages, maybe from the disk, or maybe there's something happening in the processor level. It's not being able to fetch these messages in time. So that's why we need to keep an eye on these metrics. If you see uh, a spike or a growth of these metrics, that's going to be we'll have to pay attention and uh, see why it is happening. And this PV usage, that's also I have seen, we configure Kafka, and it runs without no problem. But as you said, in the midnight, the system stops working because we are running out of disk. So like monitoring disk PV usage is super critical in that case, because these are the metrics that we usually
Forget
don't
to.
uh, don't care much, right? Yeah.
Yes,
So
exactly. Everybody's
yeah,
looking at CPU, memory, and stuff like that, which is also why we didn't include it here, because those are super common things. But these are things that people neglect, like you said, right? And comes back to bite you. Yeah.
and log flash time also related to disk PV performance usually. Uh, Yeah, so if we see an increase in log flash time, most probably it would be caused by a kind of slow disk, or the broker is getting heavy traffic, but we don't have a disk with capable I/O attached to the broker. So like those are the things that we need to tune. So if you see log flash time is increasing, or and going above the number that mm, uh, going above the standard number, so then we'll have to think about upgrading the infrastructure, update it. Either we have to reduce the incoming load. Usually that cannot be done because we have to carry the traffic, so most probably it's going to be an upgrade in the infrastructure.
Okay, gotcha. So you talked about log flush time. So one of the things that I remember when we were when I was working on message brokers, not Kafka, but like the traditional message brokers, flushing to the disk was very critical, because until it's on the disk, that means there is a chance of losing messages. I think in Kafka, Kafka mitigates that problem by replicating. It provides HA by or other fault tolerance by replicating, and then it batches the messages, and it hits the disk ever so often. That's how it can keep that performance, right? So if you write to disk more frequently, that means your performance can suffer. But if you increase that the batch that you actually write to disk, if you make it larger, the in-doubt window is higher now. If the brokers have a catastrophic failure, you may actually end up losing messages. So this log flush
Yeah.
time, and so how would someone look at? So disk is pretty clear. So like for example, for me, the disk is very clear. I can look at the usage, but the log flush time. What should I look at? Log flush time. Is it like if I'm looking at for some sort of leading indicator of trouble? How would I monitor this log flush time?
Yeah, I think it's going to be what I would recommend is having alerts monitors configured, uh, because we don't have to keep an eye on this manually, so we can configure some alert in just alert, or trigger a monitor whenever this increases, so we can
Increases.
configure it with a threshold. So yeah, I mean, our platform provides that functionality. We built some features to uh, configure these monitors. So I mean, yeah, that capabilities are there. So yeah.
Okay. Awesome. So we have some questions, and yeah, I think from Siddhant. Yeah, so this one's pretty easy, so I'll answer this myself, and I'll keep the hard one for for Srimal. That's the next one. So yeah, you should look for at least one controller, right? That's what you should monitor for. You need a minimum of one controller, Siddhant. But I mean, you could also alert on a reduction in it as well, but like at the least there should be one controller. How about the next one, Kunal? Let's bring that up. Srimal, you want to take this?
Oh, I mean, like, yeah. So this question asks about how do you correlate ISR string expand events with request latency spike? Oh, yeah. So if you see very noisy ISR string expand metric, that means there's something wrong. Most probably, like with the network or like broker resources, because instant replicas, like the replicas are able to sometimes keep up with the leader. Sometimes it falls, like falls behind. So if you see a noise in ISR string expand metric, we should definitely, like check it and see what is going on with the broker. But like we'll have to correlate it with the broker, like uh, in which broker those ISR shrink expand events happening, because that helps us to like minimize the problem and like check that exact broker. But if this metric is noisy, we'll have to like definitely check what is going on with those brokers. Most probably it is network saturation, but sometimes it could be due to JVM errors. It could be due to uh, like resource restrictions. Yeah, it could be anything, but most probably it falls under network side when it comes to heavy loads.
Okay, gotcha.
And request latency spikes, if there's no change in partition leader, there won't be any impact on request latencies, uh, because partition leader is still up and running. Uh, yeah.
Awesome. Srimal, shall we sort of look at how to visualize some of these things, and we'll talk a little bit more about the broker side before we move on to the consumer side. If you like, I can share the screen and you could talk through, and I'm just let me know, and I can scroll.
Yeah, let's do it.
Yeah, let's do this. Share my screen. Sharing screen is
Yeah, I
done.
just want to say thank you for the question, folks. Keep them coming. We are happy to take questions related to what we talked about and what we are going to talk about. So keep the questions coming in. Love this.
Right. Okay. Give me 1 second here. I now let me quickly share the screen. All right. All right. So I have a Kafka broker over here. Srimal, you wanna take it away, and I can navigate if you explain.
Yeah. Yeah. So yeah, I mean, this is a dashboard we built, like considering all of this stuff we discussed. Uh, so like it starts with, like some like very static metrics like number of brokers and number of total partitions we have in the cluster. And active controller should be one all the time. And offline partitions, if you see at least one offline partition, and if that partition belongs to like any of your critical topics, you should like take that as a critical metric, critical indicator. um, Unreplicated partitions, like if you have like any partitions which are not being able to fetch updates from the leader, like that partition becomes unreplicated. So we'll have to keep an eye on this as well. And unclean lead elections, like we talked already, like we need to have at least one instant replica ready to take over the leadership whenever the broker which holds the partition leader goes down. So but if we have a situation where we don't have any instant replicas and the partition leader goes down, that broker goes down. So a leader elected without leader elected from non instant replica. I mean, because we don't have any in-sync replicas available to take over the leadership. So controller had to, like elect a leader from one of those replicas which are not in sync. So then we treat it as unclean lead election. So that's why this metric is super important. If you see, this metric is greater than 0, that means uh, you will most probably experience a data loss. And those, instance metrics, these are like very, like regular metrics that we have in any system,
Yeah.
CPU, memory. And the important one is JVM, because Kafka runs on JVM. And JVM is, like most of the time, like memory issues are more common in JVM because
Yes.
of misconfigurations. Yeah. So we'll have to keep an eye on JVM memory utilization as well. And since we need to keep an eye on network ingress and egress, we kept those metrics here as well. So that allows you to see network egress and ingress for each broker. Uh, yeah, so we provide, like a detailed view as well. Like you can, target a broker and see these metrics and PV utilization as well. So we
So you
can
can even go
target a
down to
broker.
the level of a PV volume claim and then just visualize it in case you're like worried about, one of, some of those. So that's a great one. I think this kind of visibility, like you said, like a lot of people monitor CPU, memory, but not, and JVM for sure, because it's a known, pain point. But often forget about this. So it's something to keep an eye on because it can creep up slowly and suddenly cause a lot of grief due to an outage, and now you have to scramble to get things sorted out, right? All right,
Yeah.
so let's start here. Message consumer count. Shall I expand?
Yeah.
Probably it might be easier. Okay. All right.
Yeah.
So
We provides a detailed view, like for each topic, it shows, like how much of messages coming in. Uh, Messages out is not here because Kafka broker doesn't track it, exactly, because um, Kafka is designed in a way that, like it pushes all that consume heavy lifting into the consumer side. So broker doesn't care, like uh, of that aspect much. So that's why we don't see message out count here, but message in count is a provided metric in Kafka. So that MBIN is there. So yeah, this view just provides a detail, like we can apply filters and see for each instance, for each topic, how much of messages we receive.
all right, good. Okay. Um, Let me. So that's actually a good example, and then you can actually drill deeper into the metrics to see sort of what's going on, right? So there's a reason why we ordered these things in a such a way so that you can see the like the important metrics kind of on the top. Generally, like Srimal said, you want to pay attention to some of these highly valuable signals and the utilization. We talked about consumer message, consumer count. Um, Remember that production scenario that I explained right at the beginning. Here's a hint: those things can be avoided if you pay attention to consumer life. So when we talk about the produce and consume applications, we'll dive deeper into it. But why don't we quickly explain this part, Srima, because this is a critical metric. And then this is probably where most issues happen because, like I said, Kafka, once you configure it properly, for the most part, it's a very well battle tested, a super performant piece of software. So generally, where I find, when I worked in messaging for a long time, it's the consumer consumer side is often the culprit where you have a lot of incidents revolving around. You want to talk to us through the consumer lag, and we already have something steadily climbing.
Yeah. Yeah. So one of the like most important metrics when it comes to Kafka consumer groups, like one of the like most popular features of Kafka is that, the consumer group API. So it allows us to, like have a group of coordinated applications, like consuming from a topic, and applications, will be assigned to partitions, and applications can consume from those assigned partitions. So uh, uh, like if an application instance is not able to, consume messages, consume and process messages in time, consumer group flag goes up. That means the broker keep receiving messages, and consumer is not able to process those messages in time. So that causes consumer group flag to, go up. uh, yeah. So one of the hard parts of consumer group flag is, like, from the broker side we know there's a consumer group flag, but it's hard to correlate it to the application side, because what broker provides is, this is the consumer group name, this is the topic, this is a partition, and this is the host address of the application. So most of the time what I have experienced is that whenever we see a consumer group flag, we have to go through those tooling to, figure out which instance is that, we get the IP, and we have to log into some other tool, or we'll have to use Kafka consumer like Kafka admin CLIs, Kafka consumer groups .sh, like that is provided by Kafka, to get details of that consumer group, get the IP, and then we'll have to find out. We have to log into, cloud platform, and find out the VM which holds that IP, or like we'll have to go through Kubernetes pod list to find out which consumer instance is that. That takes time, and most of the production issues what I have experienced is that, like, we are not able to handle the pressure. With pressure makes you, doing, unexpected things. So even like little pieces of information like that misses. So uh, like that's why we try to, correlate this consumer group flag with applications, so no one has to follow those IPs, and, find out which instance is that. We do that correlation automatically through our hotel pipeline. So that allows us to create a monitor, which may trigger a monitor in that exact application whenever a consumer lag grows up. Rajit, if you can, show one of those monitors triggered. Uh,
Oh, for sure.
that would
So
be great.
actually, we'll do better yet. We can try to actually, there's a simulation running. So when we talk about consumer applications, when we explain that, we can definitely show. So I completely agree with you. Like my experience is the same, that generally, consumer applications are the major pain point of any messaging system. And then the second thing that you highlighted, which is it's easy to see from the broker that there is a consumer lag, but how do you correlate to the workload? So we are going to show that. That will be the final part of the demo. So stay tuned for that. We can show you how easy it is to add the monitor to correlate that. Okay, Srima, do you want to um, generate some monitors? So I can explain some stuff here, and we will attempt to bring one of the brokers down, and and cause some monitors to trigger. Uh, the idea here is that we want to like this try to actually do something like live, and simulate this. Bear in mind, in this particular environment, we are sharing a Kafka broker that's supposed to also process some of these signals that are coming through. It's a closed loop environment, so there might be some unforeseen, I guess, issues as well. But nothing like a live demo. So we are gonna Srimal's gonna deal with it, and I'll explain the monitors here. So Srimal talked about a couple of monitors. Meanwhile, Srimal can bring down one of the brokers. We provide a catalog of monitors to make it very easy to do monitor. So that's what people are talking about. So we, from the broker side to the consumer side, these are just cookie cutter stuff. You can also write your own custom monitors as well, which is possible. But I've added a couple monitors to kind of to show you how it is, how it can be done. So so for example, you can add stuff for under replicated partitions. So this triggers if there's at least one under replicated Kafka partition. If this is a more frequent issue that you're not too worried about, you can write a custom metric and give up a higher threshold if you want to. But for most folks, I would like to know if there's even one under replicated partition, because I want to get on top of it. So that's a monitor. Let's look at minimum brokers. So this is an important one. We talked about we accidentally added two of those, but it's fine. What this does is, if the number of brokers go below 3, you should get a monitor. So all of our monitors issues, log analysis and stuff like this, those are all connected to alerts. So you can assume if you get a monitor, you can configure an alert to go to the right team. All of that is. So I'm not going to go into that because that's a separate topic. But you can assume that you will get notified, right? So here, what the condition is, especially if you're running KRAF, right? You want to maintain quorum. And in the other case, Srimal mentioned about, if replication factor is 1, if you have a couple of those topics, some of your partitions could be offline. So it's important to have this a monitor like this. Obviously, you can also add one for JVM as well. This is for pod usage, but you could add one for JVM as well. We have one for JVM, pretty easy. You can if you can also do a percentage as well. So let's say, I don't know, 80%, 90%. Generally for Java, by the time you reach 90%, 95%, it's trouble. So you can add a percentage value as well for usage. And we already talked about offline partitions. So here's a way: if there's at least one offline partition, you will get a monitor will be triggered. Cluster degraded. Again, this is mostly. Srimal, you want to explain this about? This is if this is more about, if let's say you have a 5-node Kafka cluster, and then suddenly 1 or 2 has gone down. So you still maintain quorum. So it's not the minimum number of brokers, but something has shifted in the number, and so it's now running at a degraded state. So I've seen people running about 5 Kafka brokers in production so this is a great one to figure out that you're still not yet in trouble, but you are probably trending towards that. So keeping an eye on this. So this is where that's like a bit of an you don't have to configure any threshold. We'll just look. If you're running 5, now we are running 4, problem. The difference between this and the minimum is that's absolute minimum that you are willing to tolerate. So you see like different sort of metrics, monitors available in the built-in catalog, and you can also write your own. Did anything trigger, Srimal? Did you shut down the broker?
Yeah, I put one broker down.
Okay, so hopefully soon we should see something over here. See, give it a few minutes. Like I said, it's sometimes things works in live demo, sometimes it doesn't. Okay.
So there is a quick question related to this, Rajit. Sorry to interject. Maybe we want to
okay.
take that. That's a real quick one. Yeah.
Yes. So someone, that's a great question. It's a bit of a blast from the past. So when we worked in traditional message brokers, we were obsessed with queue depth. More or less, it's actually a little bit different in the sense that in the traditional message brokers, queue depth meant massive trouble for the broker. So the more messages backed up on the queues, the broker generally had more issues. So we monitored queue depth more from a broker perspective, and that was like a a pretty tricky situation, and you had to like quickly get on it. It's because your consumers are uh, um, the consumers are slowing down. But in Kafka, generally, the consumer lag. It's similar if you can think of it that way, but it doesn't affect Kafka the same way. At least that's my experience. It doesn't affect the same way as it did for the traditional message brokers. But the more messages backing up, is generally more of a problem on the consumer side. Srimal, is there an issue on the broker itself? If if there's more messages sort of piling up, what is
Mm,
your
I
opinion?
don't accept, I don't expect any impact on the broker side because it's just the disk which will be, clean
Exactly.
up. Because Kafka is designed in a way that like the difference in between Kafka and traditional message queues is that those message queues are designed in a way that all the heavy lifting happens in the server side in that broker implementation. But in Kafka, all the consumer heavy lifting happens in the consumer side, consumer application side. What it provides is a rich API to consume and coordinate. So we can have consumer groups. It allows us to consume messages, but it doesn't take, uh, expensive operations to the broker. It all, happens in the consumer side itself. So if you see consumer group like in Kafka, it usually, fills up the disk. But again, even if you don't see a consumer group flag, if you continue receiving messages, it fills up the disk, right? So until it reaches that retention policy. So that's the difference in between, those traditional queues and Kafka. So consumer group flag would not make any impact on a broker. Yeah.
Oh, okay, gotcha. Right. So my understanding is correct then. Because I haven't seen that kind of like pressure on the broker. It's mostly the pressure is on the consumer applications. But in the traditional messaging side, queue depth is can be fatal to the brokers, and that's generally where the brokers topple. Yes.
So I think
Yes.
this is a continuation of the question. Yeah.
Yeah, so actually that's a good way to sort of look at it, because the when the consumer side is slowing down, you're going to have upstream and downstream impacts on your business flow, right? Generally, you're doing some sort of transaction, and this puts pressure on your which puts pressure on your ability to process those business transactions, right? And this will manifest most likely in other areas as well, right? So, for example, if it's an order processing system, suddenly you have a bit of a backlog of orders being processed, and people are not able to either place orders, or they're going to see a significant delay in getting their responses and stuff like that. So, if you're doing some sort of SLO monitoring on the number of orders processed, or the average response, so the average time it takes to process an order, those things will start to trend up. So you can definitely tie into it. I hope I explained it to you, or did you have a different sort of ask here? I'm just trying to understand it. I'm hoping I understood your question correctly. So feel free to mention if I didn't explain it properly. Uh, Sorry, I can't see your name. But if you want us to clarify, or if you have follow up, oh, that is fine. Okay, thanks. Appreciate it. Good. Oh, I looks like I stopped sharing my screen. Let me share it again. Where is it? Yeah. So
We also got a comment about the monitor templates that you were showing previously.
Okay, yeah. If you can ask me, so there is this is the Kafka one, the minimum broker thing. There is alerted value. So we wanted a minimum 3, but you got only 2. So we were able to trigger it up. Maybe we might want to scale it back up so it doesn't affect the rest of the sort of the demo. Yeah. What was the question again, Kuna?
Oh, it wasn't a question. This person loved the built-in monitors that you showed earlier.
Oh,
They
thank
love
you.
the
I
way we structured
appreciate
it.
it. Yeah, we figured that, I mean, we use Kafka heavily in production, and eh, when we, I used to do consulting before, and it was really tough sometimes to write these monitors. Why not? These are things that can help people. So that's the kind of idea behind it. I appreciate your comment. Thank you. All right. So, Srimal, maybe before we go onto the consumer, producer and consumer side, one other thing I want to talk about, something that's pretty powerful in the platform we provide, which is log analyzers. We didn't recreate that, but I want to talk to you. Can we talk a little bit about the log analyzers? So this is real-time log monitoring. Generally, there are lots of things that you might want to keep an eye on from a Kafka logs perspective, right? Instead of people looking through the logs, or this is a way for you to monitor logs. By the way, this real-time log monitoring is, it's for any application that we monitor, and that's one of our key features where we can provide real-time log monitoring without the ingestion costs. So can you talk to a little bit about this, Srimal? Like, why is this kind of important? And this is an example.
Yeah, so I mean, like one of the missing parts is that like we deploy Kafka and it runs without any issues because we don't see some stuff in metrics, but something is happening in the background which may like end up like triggering something bigger, some cascading failure. So that's why we need to like keep an eye on Kafka logs as well. So like this is one example. So a broker complains about there's a like partition that has replication factor. Let's say we have replication factor 3, and it is not being able to like catch up with that like replication factor. It's not being able to create those like required replicas. So like these kind of exceptions like can trigger time to time and can get resolved automatically as well, but it's important to keep an eye on these logs. That is not something we can do manually, right? I mean, we can't do like we can't go through these logs every day. So that's not something we should do. So instead of doing that, we can just configure a log analyzer, capturing those critical log entries in Kafka, and whenever that log entry emits, we will like get a notification. So that's the idea of this feature, and we can like add more and more log analyzers targeting those critical Kafka logs. This is a generic feature that we provide for all the applications that we monitor, but will help in Kafka monitoring as well.
Yeah, that's actually a great point. And generally, like the way we use it. So when we encounter issues in production, and we whether it's Kafka or anything else, we try to add that as a log analyzer. So most teams, like every situation is different, and you might be experiencing some issues that others don't. So your setup very well. So what you need to do is, when you get these kind of issues, and what you have seen in the logs, you can use that as a hint to do more proactive monitoring for the next time it happens, right? Or if you already know some of the gotchas, you can configure it. So what we do is we generally look for bleeding indicators of trouble in the logs. We create log analysis for those patterns, and when production incidents happens, one of the key learnings is we look for log patterns that we can monitor going forward, right? So this is a great way of kind of like learning from outages and incidents, and then capturing that knowledge and like adding that to automatic monitoring going forward, right? So good. All right, so we talked about that as well. And then how about we switch tracks and go back to talk about producer and consumer application. So I'm gonna stop sharing my screen. Kunal, uh, you wanna start the slide deck? We'll go to the other one. Okay, good. Oof. All right. Okay, Srimal, let's talk a little bit about the producer side metrics and consumer side metrics. I think keeping an eye on the time as well. I think let's go through the slide deck and then finally go for the demo. So on generally when you're producing and consuming, there are a couple things that you want to keep an eye on. Talk to us about the why these are important. Arguably, I've rarely seen producers having trouble, but it's mostly consumers. But humor me and explain this, and then we'll jump onto the consumer side.
Yeah, so request rate is, kind of like a very common metric that we keep an eye on. Uh, Basically, it shows, like how much of messages it produces per second. Uh, that's a very basic metric. And request latency, like how much of time Kafka broker, takes to respond to that request, because a request can, like contain one message or a batch of messages. Uh, so request latency, like if you, like if you're not using batch producer, then request latency is going to be, like very small number. But if you're using a batch producer, it's going to be, like somewhat high. That's natural. And again, like error rates, like most of the Kafka producer libraries, wrappers, like have inbuilt retry mechanisms as well. So if it has a retry mechanism, we'll have to keep an eye on that as well, because more retries means something is wrong in the, like maybe in the network level or the broker level. So we'll have to keep an eye on the retry rate as well. So these are like very basic metrics that we need to keep an eye when it comes to producer side of Kafka applications. Yeah, I think that sums it up, Rajit.
Okay, awesome. Let's move on to the consumer side, and let's talk about this. Srimal, go for it. I mean, we already talked about the consumer group lag, and then one of the more important parts is to how you can correlate consumer group lag to a particular consumer. We'll show you that in a second. Maybe take a second or two to explain the other stuff as well.
Yeah, I think like we talked about consumer group lag, the consumer is not being able to consume and process messages in time, that like may lead to like pile up messages in the broker side. So and the consumption rate, like the messages consumed per second, uh, like uh, so if you have like multiple consumers running, and if you take a closer look at each of those consumers in the group, and if you see a kind of imbalance in consumption rates, that means you have something to fix in the a message producer side, because messages are not evenly distributed across those partitions. So if you see consumption rate not even in the consumer group, that's something like which signals us to take a look at the load distribution. So most probably it's going to be the producer side which produces the message, so it has to distribute the load, distribute the message load across all those partitions. So that's how consumers get an even load. uh, Processing latency, this is a kind of like custom metric that we see in most of the consumer applications, which tells us how much of time the application takes to process a single message. uh, so it may contain the latency is caused by databases, caused by like other IO operations. But it basically says how much of time the application takes to consume a single message. Processing errors, again, a metric exposed by applications usually to signal us about processing errors happen in, when it processes those incoming messages. Commit errors are more related to consumer groups, because consumer groups will have to, commit the group offset time to time. So yeah, we don't have to, do it for each and every message, because that may, create an additional overhead in terms of, networking, and, uh, create a, creates a pressure on Kafka broker side as well, because whenever we commit a group offset, it has to, publish a new message uh, to an internal topic called the consumer group offsets. So that's how Kafka keeps the group offset. So we don't have to, consumers doesn't have to, do not have to commit it for each and every message. But what usually happens is that it processes a batch and commit that batch. So in that way, we can reduce, that overhead. Uh, yeah, I mean, these are the important metrics when it comes to consumer side metrics, Rajat. Yeah.
Awesome. All right. Before we jump onto the demo, let's, in the interest of time, shall we tackle the how we monitor stuff, and that's probably important to tackle. So, yeah, right. So that's the sort of like the traditional monitoring. I'll speak to this part, and then Srimal can tackle the other one. Generally, people deploy JMX agent and then grab the scrape them into Prometheus, and then build dashboards or consume from there. Or you deploy some sort of proprietary agent to grab these metrics, right? But we have OpenTelemetry now, so let's go to the next slide, and Srimal, you can explain to us about the OpenTelemetry way of doing these things. Yes.
Yeah. So instead of, having the JMX agent running inside Kafka, so this is how we can do it using OpenTelemetry collectors. We can build an OpenTelemetry pipeline, and we can uh, configure receiver. So we have our own OpenTelemetry collector distribution. So that has some, additional metric scrapers, which consumes some extra APIs of Kafka. So it's just not, the JMX metrics published by brokers. Uh, we also consume the Kafka admin API to, collect some metrics. So that's why we have our own hotel collector distribution. So we can, you can use that distribution and configure the hotel collector to, scrape all those metrics from Kafka. That means we are collecting JMX metrics plus the metrics coming through the management API.
Awesome. We have a generic article on that talks about monitoring Kafka with OpenTelemetry. If anyone kind of wants to get started with the open source approach, Kunal, you can link that. Provide that link over here. Let's jump into the demo here, Srimal. We've already kind of done the scenarios on the broker side. We just, in the interest of time, we brought down on broker, and then we showed that we were able to, simulate the minimum number of brokers. But if you create enough chaos, you can, simulate the rest as well. So, in the interest of time, we're not going to go through that. But on the application side, let me walk you through. We simulated a delay in consumer lag, and then we can show how that is, affect how you can correlate the consumer lag to a specific consumer application, as well as, show you how you can look at producer and consumer latency for an application itself. So let me share my screen and wrap this up. I think I'm showing the right screen. Let me see. I have a couple. Oh, so it's the wrong screen. So let me go back to the other one. Yeah. All right. So for this particular one, what you're seeing here is that there's definitely error logs as well. So something is going wrong in this service. This is using Kafka, and it's consuming from this particular order processing service. So first of all, you are able to look at the processing pipeline, latency, like Srimal talked about, and there is some error. So the error is actually happening when it's trying to, do the corresponding application. It's making a put, like making an HTTP, so processing the message, taking and actually creating, invoking an HTTP endpoint to do the second action. So what is happening is that is failing. In this case, almost 100%. So because of that situation, I think we ran the simulation a little too much because it's failing, and it's holding things up. Suddenly, your consumer lag is building, right? Things are going south. So here you are able to kind of look at the inbound, so the consumer latency, the consumer throughput, as well as the errors associated with it. In this case, the error manifested in sort of like the outbound call when you process the message. So you can get insight into that aspect. And then we talked about monitors in over here. I mean, it's also reflected in the traces here as well, and the logs. So if you go to the monitors on the application side, remember I talked about there's multiple things that you can do. So here I've added, something for the error rates itself, but I added it to the wrong side. So that's why you will not see anything there. But in the latency, the order processing latency of fraud scores. So here, I've added something on the message processing, because this correctly identifies that this service is consuming from the order process, topic, and if it exceeds this particular latency, I wanted an alert, and then the consumer group, like that Srimal talked about. So here I've given a very small threshold. It's actually pretty high right now. So you can say if my lag is, I don't know, 10, 50, 20 messages. This depends from team to team. So for example, for some applications, you can tolerate a lag of 100, but other critical applications, you probably don't want to tolerate more than a couple messages, because it's super critical to consume it as fast as possible. So you can tune it to your requirements to set up a consumer group lag. So what happens is when this consumer group lag gets triggered, we are able to, this is the order latency one. We've simulated too much, so it's now in seconds instead of milliseconds. There should be one for the the consumer group lag over here. See, there you go. That's just that one. So what Srimal talked about is generally it's hard to pinpoint it back to the actual application that is causing it. Even pinpoints it to the pod that is actually. So if you have multiple pods, this is very important, right? We should have probably run a couple more pods, Srimal. So it's very important if you're having, let's say, 5 replicas processing it. The problem could be in a single pod because of some other issue, right? So we are able to pinpoint the lag for that particular partition to a particular pod, or if you run in a VM in the future, to a particular instance running in a VM. So that is important, because normally teams correlate this manually, right? You look at some other tools from somewhere, put things together, and then arrive at this. Here you will get an alert right away, because you can alert on monitors. It will have the information right away to say, like, which application and which specific instance of that application is experiencing the lag. All right, so I think we've kind of gone through the sort of the situations here. Please, if you have any kind of questions, we're happy to answer them. You can also reach out to us anytime. Happy to have a chat, and we can definitely continue this conversation offline on LinkedIn, or through the comments as well.
Amazing. Yeah. Thank you so much, Rajat and Shrimal, for sharing this information. I know we've been going for a while, but I feel that There was a lot of valuable information shared today, and I've been sharing all of the links that we mentioned for the folks who have been staying till now. We have all right now got around 10 to 12 folks watching. So thank you so much for staying this late. Throughout the entire session, you can access all the links that I've been sharing via YouTube, because last time we got a suggestion that they are not able to view people are not able to view the links on LinkedIn. That's something on the LinkedIn side. I'm sorry about that. But if you wish to learn more about what we have been sharing, you can access all the links on YouTube, and I'll make sure that once the recording is uploaded, I'll add the links to the description box as well. But again, thank you so much, folks. And if you have got any questions, feel free to drop them as well, and I'll make sure to ping either Rajat and Shrimal so that they are able to answer your questions. But do we have any closing remarks from either of you? Rajat, do you have any closing remarks from your end?
Nothing much. I just want to thank everyone for tuning in, and we hope you enjoyed it. Thank you very much. I really appreciate that comment. And we look forward to doing more of these webinars in the future. Talking about real production scenarios and how to monitor them. Yeah.
Amazing. Yeah. Shrimal, what about you? Any closing remarks for your end?
No, I mean, like we've been, spending time on building this for some time, and we have, like lots of plans in our mind as well. So like we'll be implementing those in future as well. So yeah, we'll see you all in future sessions as well with all those, like new exciting features.
Awesome.
Amazing. Yeah. Thank you so much, everyone, for attending, and we'll see you in the next session. Bye bye.
All right. See you guys. Bye bye.
Thank you, everyone. Bye bye.